Hey guys, we are on to part 2 talking about our parallel lines and angles. We got cut off right in the middle of that last one, so let's just pick up where we left off. We said that 5 and 7 were corresponding angles because they were on the same side of the transversal. They're both down and to the left of those intersected lines being cut by the transversal, and we were getting ready to identify 2 and 7. We said 2 and 7 were inside or in between the two lines that were being cut by the transversal, so that made them interior lines. And then we noticed that they were not on the same side, they're on alternate sides, so that is our alternate interior angles. Let's find 1 and 3. All right, I see that 1 and 3 again are on the same side of the transversal, and they're both left of the lines that are being crossed. So they're both up and to the left of those intersections, 1 and 3. And we know then that they are corresponding angles because they are on the same side, relative same side of the transversal and the lines being intersected. 5 and 8, here's 5 and here's 8. I notice that they're both on the outside. It kind of looks like an H. So on the outside of the H, or the outside of the intersected lines, that makes them exterior angles. And they are on the same side of the transversal, so they are consecutive exterior angles. They're both down underneath that transversal. All right, what I would like for you to do is to go ahead and pause the video and try example 4 on your own. Remember that your choices are corresponding, alternate interior, alternate exterior, and then consecutive interior or exterior. You also have the option to do none. So let's take a look at one that is a none. We have angle 6 and angle 11 here. Okay, at first I'm like, okay, so they're both on the outside of the lines being cut, but we've got two transversals in this one. We've got C and we've got D. And angle 11 is over here by transversal D, and angle 6 is by transversal C, and therefore they don't have any relationship to each other. So we're going to go ahead and fill in H, none. Okay. So when you're comparing these angles, these 8 angles are on the same transversal. So they could be consecutive, corresponding, etc. And these 8 angles are all surrounding transversal D, so they have some kind of relationship. So pause the video, do what you can. We'll check example 4 when you come to class on Tuesday and see how you did. All right, so we started off by talking about parallel lines as coplanar lines that never intersect. And then we introduced transversals, and these transversals were just cutting any old lines, right? P and Q are not parallel. They're just two lines being intersected by transversal R. Well, now we're going to take a look at what happens when parallel lines are cut by a transversal. And when parallel lines are cut by a transversal, we still have those same relationships in our angles, but something neat happens to the angles. Our corresponding angles, those are the ones in the same position relative to the transversal in the intersected lines. Our corresponding angles are going to be congruent. Our corresponding angles are going to be congruent. So let's see if I can draw a picture here. Just imagine that these are parallel. And here is our transversal. That's not a great picture. All right, but our corresponding angles, those are the ones in the same position relative to the intersection. So let's say angle 1 and angle 2. They're both up and to the left here, right? Above the transversal and to the left of the parallel lines. 1 and 2, and it's kind of hard to tell with my not so well drawn picture, but 1 and 2 are corresponding and they are congruent. They're both actually obtuse angles. Alternate interior angles, so let's see, 2 is interior, let's make this a 3 here. So 2 and 3, both interior, alternate interior angles. I don't know if you can tell by looking at the picture, but they are also congruent. Alternate exterior angles, so let's see, 1 is exterior, so let's make 4 exterior. So 1 and 4, alternate exterior angles. Again, I don't know if you can tell by looking at the picture, but they are also congruent. All of those are obtuse angles. Now, consecutive same side interior angles. So let's see, we've got 2 right here, and let's do maybe 5. So 2 and 5, consecutive same side, interior angles are not congruent. You can tell that 2 is obtuse and 5 is acute. So the interesting thing about 2 and 5 is that they are supplementary. Remember that supplementary means that if we were to add these, we just have to, they're going to add up to 180 degrees. That's going to be coming in handy when we try to find some missing angles here in a moment. We just have to remember that everything adds up to 180. Consecutive same side exterior angles, let's make this like 1 and 6. If you take a look at it, this is obtuse, this is acute, and if you're guessing, is it also supplementary? You are correct. They are also supplementary. Remember from Unit 1 that vertical angles are always congruent, so 1 and 3 are congruent, and 6 and, let's make this 7, 6 and 7 would be congruent. Our vertical angles there are going to be the same, and that angles that form a linear pair, so they're side by side there, and they are supplementary. They add up to 180, so 6 and 4, that's our linear pair there. They add up to 180. They are supplementary. So let's keep all of that information in mind and see if we can find some missing angles. We've got to identify the angle pair as either congruent or supplementary and give our reasoning. And our reasoning is not going to be because they look the same or because they look different. We have to identify what type of angle it is. So let's take a look at 3 and 5. By looking at them, I can say, yep, those look like they're the same. They're both acute. They are, in fact, congruent. And the reason that they're congruent is because of the type of angle they are. They are alternate interior angles. They're inside the parallel lines. Here's my parallel lines, and they're on alternate sides of the transversal. It does help if you identify right at the beginning where your parallel lines are and where your transversal is. That might help you. Right? And then we have 1 and 8. We know that 1 and 8 are here, an acute angle, and here, an obtuse angle. So we're going to say that those are supplementary. They're clearly not congruent. And the reason that they are supplementary, because of the angle type, they are on the same side, so they're consecutive. And they're both exterior. They're both outside. One's above and one's below the parallel line. So consecutive exterior angles. All right, let's quickly breeze through these, but I do want you to take a look at the pictures as well. So we've got 2 and 6, both obtuse. They're both going to be congruent. And the reason that they are congruent is because they are corresponding angles. I am abbreviating everything. I would encourage you to write it out. 1 and 7, looking at those. Yep, they look exactly the same. They're both acute. They are also congruent. And the reason that they are congruent is because they are alternate exterior. Now keep in mind that these rules about congruent and supplementary only apply to parallel lines cut by a transversal. Not all lines cut by a transversal, just the parallel lines cut by a transversal. Can we apply these rules of congruent and supplementary? 4 and 5 are supplementary. If you take a look at them, you'll see that one is acute and one is obtuse. And the reason being they are consecutive interior angles. Let's identify those with the mouse here. Here's 4, here's 5. They're on the same side, both inside the parallel lines, consecutive interior. 3 and 7 are congruent, and the reason that they are congruent is because they are corresponding. They're on the same relative position. They're both, if we find that point of intersection, they're down and to the right. Here's our point of intersection, down and to the right. 5 and 6 are supplementary, and the reason that 5 and 6 are supplementary is not because of a special angle pair, but they're right next to each other. Right next to each other, their bases form a straight line, and we call that a linear pair. So that is why they are supplementary. So we're going to write linear pair. And last but not least, 2 and 4. It's kind of hard to see, but here's 2, here's 4. And they are congruent, not because of any special rules we've learned today, but because of one we learned already before, because of the vertical angle theorem. They are vertical angles. All right, again, what I want you to do is pause the video here just for a second and see if you can figure out the rest of this slide here. And I'm not sure that you can actually see the bottom example. Let's pull that down, see if that helps you here. Now this one, the instructions are a little bit different, so I'm going to get you started. We're told that angle 1 is 65 degrees. And what I like to do is find all the other angles that I know are 65. Well, I know that 3 is 65 because of the vertical angle theorem, so I'm going to go over here and write that, 65. But there's some other angles that are also congruent that I know because of some other rules that we just learned that are also 65 degrees. So we're going to see if you can find those on your own. The other thing I know that 1 and 2 are a linear pair. Okay, their bottom rays form a straight angle here. So all I have to do to find angle 2 is take my 180 degrees minus 65, and I get 115. So I've got angle 2 is 115 degrees. Now, if I know angle 2, because of the vertical angle theorem, I also know angle 4, 115 degrees. What you should find is that every angle in here is either going to be 65 or 115 degrees. Now, you do have to give your reasoning. I did mention the reasoning. For example, angle 3, we said it was 65 degrees because it's a vertical angle. And the angle 2 is 115 because it's a linear pair with angle 1. And angle 4 we said was 115 because it's a vertical angle with angle 2. So you're going to give your reasoning as you finish that and try that on your own. We will check that in class also. So do your best. We'll see how you do. Pause the video right here and try to finish that. All right, guys, that brings us to example 3. Example 3 is very similar to example 2. We're given a unit of measure, and we have to fill in everything else that we don't know, and we have to give our reasoning. So measure of angle 1, or we're told the measure of angle 6 right here, that obtuse angle is 142 degrees. So I'm going to go ahead and do the vertical angle. Angle 1 is also 142 degrees. And the reason it's 142 is because it's vertical to angle 6. So when we write that reasoning, vertical to angle 6, that's one way that we could write that. Well, if 6 is 142, I know that its linear pair is angle 2. So I'm going to take 180 degrees and subtract 142, and that will tell me that angle 2 is 38 degrees. So measure of angle 2, I guess I could write that right there, 38 degrees. And my reasoning is it is a linear pair. Linear pair with angle 6. Now, if this one is 38 degrees, using the vertical angle theorem, I also know angle 5. So I got you started. You can see if you can finish that. Remember, all of your angles will either be 142 or 38, those two numbers. You shouldn't have any other numbers. They're either supplementary or they're congruent based on what you already learned previously in this video. So do your best to finish that. All right, guys, we are quickly running out of time. We have just about a minute and a half left in this video before it cuts me off again. And I want you to tackle these on your own. Again, I'm going to get you started, but I'm not going to finish the whole thing. We've got parallel line, parallel, parallel line. And here is our transversal. We're going to identify that first. And we're told one piece of information, the angle 5. Angle 5 is 82 degrees. Based on that one piece of information, we can go figure out all the rest of these angles. Maybe you want to figure out 11 first using the linear pair theorem. And if you do that, you're going to find out that angle 11 is 98 degrees. You don't have to identify the reason here. Or maybe you wanted to start with the vertical angle theorem. And if you did that, you would find that angle 8 is 82 degrees. You're then going to apply all of those other theorems, alternate interior, alternate exterior, consecutive, corresponding. All of your angles should be 82 or 98 degrees. Try the same thing with angle 5, although it's getting a little bit trickier. Angle 5, here's our two parallel lines, and this time we've got two transversals. So we're going to have maybe more than two numbers this time here, two transversals. We're told that angle 12 is 121. And if I know angle 12, I know angle 11. Part plus part equals whole. So if this whole thing is 180 degrees, then I know that angle 11 must be 59 degrees. So let's go over here, 59 degrees. I'm also told that angle 6 is